Hi and welcome. It's the 12th of August 2014. Guys, I'm back on the National Weather Service modelling system, and as you can see I'm at 10 HPA, and there is something missing quite clearly on the northern hemisphere of the Earth over the Arctic Circle. And what I want to do first of all is show you, as I have done many times, it's for the benefit of people that haven't seen this, because I feel it's of importance and there's some investigation to do here, and I have been doing a little bit, and I want to just show you the results of what I've come to the conclusion and the conclusions on those results. So we can see there is not a lot of activity at all over the northern hemisphere. If I would just bring up various let's look at, we're looking at wind at the moment, but you can see there is very little. I'll turn it to temperature. Again, there is more going on other parts of the world. Let's look at the residual humidity, or the relative humidity. You can see again there is very little over the northern hemisphere. And if we turn to the wind power density, we get readings for these regions. If I click on these, we can get readings for these regions, but very little over these areas. So something's missing on this part of the Earth, and I just want to show you that. If I just go back to temperature, because it gives us, or wind actually, it gives us a better look at what's there and what isn't. We can see that there is not a lot of activity over the northern hemisphere, and if I give you a look at the equatorial region, we can see that the rest of the Earth is enjoying some form of activity with regards to that. The Antarctic, a very strong system over the Antarctic at that altitude. Why do I say that altitude? Because if we go back onto this, you can see at surface, right, if we look at the surface areas, there is pretty much more going on over the northern hemisphere at the surface. Look at temperature, relative humidity. You see what I mean? It's only until you back it right out into the meosphere that you see there is changes. So what I thought I'd do is I'd find out what 10 HPA corresponds to altitude, and perhaps we could see therefore what was missing right now on the Earth with regards to this, because you can quite clearly see, as I can, that there is something missing over the northern hemisphere compared to anywhere else on the Earth. Over the Antarctic region, and over the Arctic region. Okay, so let's see what that 10 HPA corresponds to with regards to altitude. Let's see if we can find a calculator that will give us an altitude, and then let's have a look at what part of the atmosphere we're actually looking at. Maybe that will give us a clue as to what is missing over the northern hemisphere. Okay, so at the moment I found a graph, and as we can see is atmospheric pressure V's altitude, computed for 15 degrees Celsius at 0% humidity. So what we're looking at here is KPA, not HPA, so we've got to times that by 1,000. Right, so that would give us surface. So at 1,000 KPA, HPA, instead of it, because we've times it by 10, we're getting the HPA. So if that's 1,000, we'd be looking at, on that graph that I just showed you on here. If I just give, I ain't going to be able to show you on that, but take it from me, when we go back onto the computer modelling system, that is at surface level. Right, and we can see where we want to be at 0, because that's what we was looking at, or 10%, which is at the bottom of the graph. We're looking at an altitude. Remember, it's in meters, so we knock a 0 off to find it in kilometers, and we're looking around about 10,000 kilometers. Sorry, 10 kilometers in altitude above the Earth. So what we want to do, just to be sure, we know we're in the 10 kilometers region above the surface of the Earth, so we want to know what part of the atmosphere we're looking at that is missing on the northern hemisphere. Let's see if we can find a calculator and just get a better accurate reading as to the altitude, because it's very important. Okay, we've found a altitude air pressure calculator. So remember, it's measuring at the moment in meters or feet, so we'll leave it in meters. So we knock the first 3 zeros off there then to give us kilometers. So we have 10% HPA on the bottom, and we've got an altitude of 15 kilometers. And just to show you, if I alter the you can see it's at 10%. That's what we want, because we was looking at 10% on the weather modelling system, where we've noticed something's missing. What we're doing here, guys, is we're just trying to find out whereabouts in the atmosphere that something is missing, and it will give us an idea as to what it is that is missing. Right, so just if I change that 5 to a 0, we can see it increases the HPA, or the percentage of that there, the pressure. So we want to keep it at around about 10% to give us the correct altitude, because we know that whatever we're looking at is above 10 kilometers at the moment, because we haven't matched the humidity with the altitude at the moment. So if I just knock that 0 off, put the 5 back, we can see it goes down to around 10%, and it gives us an altitude now of where we're looking at. So we just need to find out now. We need a diagram showing us the altitude, and therefore we can find out what is actually missing from the northern hemisphere. So let's do that. So now we've got our breakdown of the atmosphere. We're looking for somewhere between or around 15 kilometers, so that puts us in the Narcurus cloud region, which is in the troposphere, and it is also very close to the ozone layer, interestingly. Now, is it the ozone layer that is missing from the northern hemisphere? Well, you'd think mainstream media would report if the ozone layer had such a rip over the northern hemisphere, wouldn't you guys? I'm not saying that it is. All I'm saying is that there is no relative humidity in that area. There is no signs of weather across the range of what we're able to see on the the northern hemisphere of that weather modelling system. Let's just look at something else on there now. Okay, if the ozone layer had gone, would it be warmer over the Arctic region at that altitude than it would be, say, somewhere over the equatorial region and the Antarctic region? Because you'd expect, if the ozone layer had gone, the area or the vicinity of where this anomaly has appeared, you would expect it to be warmer over those regions. So let's go back onto the weather modelling system then and see whether it is actually warmer over those regions, because I would expect if the ozone layer had gone, it would be warmer over those regions. Okay, let's just do it. Let's have a look. So here we are back on the weather modelling system. We can see that there's this anomaly of nothing taking place over the northern hemisphere, or at least over the Arctic Circle, and you can see that we're at 10 HPA. That corresponds to 15 kilometers above the surface, the sea surface, or at least 15 kilometers of altitude. And we're just looking at temperatures over that region now. I'm just going to shut down this section here, and we can see the temperature over these regions is minus 36 degrees Celsius. I'll just check it a few places. 36, 35, and remember this is corresponding to an altitude of 15 kilometers. Right, so if we go over to the side around the equatorial region, we can see straight away that it's warm, much colder over the equatorial region. But there's a lot more going on at that altitude in the atmosphere. Let's just check that again, closer to the equatorial region. Right, so we're right on the equatorial region. We're at minus 41 degrees. Still, the northern hemisphere is the warmest. We're going to go further down, minus 45 degrees. And we're going to check slap bang in the centre of the Arctic Circle for the temperature there. Right, we've got a minus 83.5 degrees Celsius. So it certainly looks as though, as you can see, guys, it certainly looks that the northern hemisphere is the warmest part, as well as being the part on the Earth that seems to not having a very much happening. What does this mean? Does it mean the ozone layer has deteriorated over the northern hemisphere of the Earth? And is that a result of the splitting magnetic pole? Well, it's like I said to you guys before, these coldest regions don't occur over the dipoles on the Earth, and they certainly don't, there's no coincidence in the fact that it's also the point at which the Earth rotates on its axis. So, to draw a conclusion, it certainly seems as though something is missing in the atmosphere over the northern hemisphere of the Earth. Is that the ozone layer? It could quite possibly be, as we have just found out. It is within the vicinity of that area of altitude that we are looking at, 15 kilometers. Where the ozone layer starts. Well, the ozone layer also protects us from, a lot of, extra heating of the planet. My conclusion, my gut says that is the ozone layer that's gone there, but my goodness me, if that is the ozone layer that has deteriorated to that degree, then there is a large hole over the Arctic region of the Earth right now. If you've noticed that I've made any mistakes in this, please point them out. I would like nothing more than more scientists or climatologists get involved in this, trying to figure out what is driving our climate to the extremes that it is right now. We know that the jet stream is pushing way below where it should be. It's usually in the UK here, it's usually above Scotland. We know that it's below at the moment, the south coast of England. So, what's responsible for that? Is it the magnetic weakening of the magnetosphere in the Earth that is driving this? Because I've said this several times, guys, there is no coincidence that we have a magnetic pole over the coldest regions of the Earth, the Arctic and the Antarctic, and they are also on the the rotation axis. Now, I would suspect if we are seeing the pole over the northern hemisphere, as I've concluded, that it's splitting. When it splits, will a rotational axis at that point shift? I don't know, guys. I'm just trying to get to the bottom of this. You can see the length of work that goes involved in this, just trying to do some, digging around to find out what is actually going on. We think we've got a bit of a result here. We can see that at the moment, over the Arctic region, it's quite warm compared to anywhere else on the Earth. So that, could be the fact that if we just go back onto that graph again, where we look at the atmosphere. So here we are back on the breakdown of the atmosphere, and we can see the tropopause is at 12 kilometers. We need to be looking around 15 kilometers. So, it's within that region of the ozone layer, guys, where something has gone wrong over the northern hemisphere. I think it's likely it's the ozone layer that's not there. And I think the fact that we've just took temperature readings from the north and the equatorial region and the Antarctic region, we see that the rest of those areas that are enjoying some activity are a lot cooler. But when we look at over the northern hemisphere at 15 kilometers, we see that it's the warmest place on the Earth, and that's wrong. So I'm suggesting that there could be, at this moment, and has been for, I don't know how long it's been like that for, but there is a large gaping hole over the Arctic region. Whether that's linked to the magnetic dislocation of the North Pole at the moment, is yet to be concluded. But I think this is some supportive evidence to at least suggest that is the case. You've seen how we've broke this down. We've found out what part of the atmosphere 10 HPA corresponds to. So we know we're looking at 15 kilometers above the surface of the Earth, and that puts us within the tropospores and above. So certainly within the vicinity of the ozone layer. And we know how that protects the Earth by keeping it, by regulating its, surface temperature, or the mean surface temperature. Guys, like I say, I welcome any other scientists to jump on this with me. I've been pushing this cart pretty much on my own for 3 years, trying to figure out, what's going on with the climate and the solar system. It requires a lot of my time. Again, today I've spent 4 or 5 hours just on this. So if you can support this channel, I think what you'll probably get out of it is a heads up of what's to come, and that quite clearly if the things stay the same as what they are, we're looking for a very severe drop in climate. Now I know you might say, well, how come what we're looking at here is showing a warmer structure over the northern hemisphere? Well, it's not the ozone that is the driver of the climate, I'm afraid. It's what we get off the sun, and that is, as we put in the video yesterday, we can see that there is obviously something changing with the photosphere on the sun, and that is the emitter of radiation. And we've seen Livingston and Penn's report show that these sunspots are on the way out, and we're very close to that point, guys. It's a very exciting moment, because we're very close to seeing those sunspots drop out. And if I had more time in this video, I would show you just what is recently occurring again this month with sunspots on Solarham. Because if you check yourself, just look at August, there was a dip in the sunspots midway through, and then now we seem to be going through another dip, and I predict over the next couple of weeks there will be a few days, or at least a day, where there's no sunspots noticeable on the disk. And this is all leading up to confirm and compound what Livingston and Penn said about the increase in surface temperature on the sun and the decrease in magnetic gores and sunspots as a result. So we're seeing it like real time, guys. I just hope people are paying attention. The fact is, I know I'm not fussed about the fact we've got 1,500 subscribers on the channel. I'm not fussed about that one bit, but I would rather it be a lot more than what it is. And I would rather more people support this work, because it's important, guys. What we're seeing take place today, right? Okay, put what's happening in Gaza on the side, what's happening in Syria, what's happening in Lebanon, Libya, Iraq, and all the conniving scumbags of the governments of the Western world, and trying to blow up airplanes, kill people. Put all that on the side. What we're looking at affects everybody on this planet, and we are coming to the crescendo. This is on your doorstep, guys. It's on your doorstep. If the sunspots vanish in 2015, in December, January, February, or it could even be late 2015, if they go, climate is going to plummet. Is it going to be a minor event or a major event? If you ask me, it's a major event. And the reason why I say that is because back in the 1650s, the magnetic pole wasn't migrating at the rate it was today. We're going to go, I feel, for the big one, the big ice age, the one that affects all of this planet. And it's overdue. Scientists know it's overdue. And I'll tell you this as well, you always get a warm period before an ice age takes place. So all these climatologists that are banging on about global warming right now, you know what, this could just be the nature in which ice ages come about, guys. That's all I want to say. So as usual, guys, you can support the channel, the link's below. You know, there really needs to be more than 2 people a month that are throwing, you know, a few quid towards this research. You know, what I'm asking for is some support from you guys. You can see I'll put an effort into getting the information out to you, and I'll try and do it and present it in an honest way. You know, I'm not trying to make myself a rich man, but what I'm saying is it would be nice if I could get a bit of financial support from a few more than 2 people a month. And for those that have supported the channel in the past, you know, I can only say thank you, guys, because, you know, I know you get something out of it yourself, and I know you don't just do it for yourself, you do it for others. And that's what we should be doing right now, working together. So as usual, guys, you know, time for preparations, time, you know, to start paying attention, start talking about it with your families, you know, start thinking about your finances, where you want to be in the coming years. And as I always do say, guys, bye for now.